For the second part of our experiment, we're going to be holding velocity constant and changing the radius of the ladybug. This is slightly harder than it seems. And so we can start with the ladybug at the 1 meter mark. And we will start her off with an angular velocity of 360 degrees a second. And just watch carefully, make sure that that stays at 360 degrees per second. And there we go. Okay, I can measure my velocity vector and my centripetal acceleration vector just fine. Now, the trick comes when I start moving my ladybug. So hit reset all. I am going to change her to 2 meters from the center. And what I'm going to do is I need to change my angular velocity. So I started out at 360 degrees per second. Because my radius has changed, and I want to hold my angular velocity, or sorry, my linear velocity vector constant, I am going to have to lower the angular velocity. Before, she went around the whole circle once every second. Now that I've doubled the circumference that she covers, I am going to have to drop the angular velocity in half. Now, here's a question for you. When we go to do this experiment at 3 meters, slow down, ladybug. When we do this at 3 meters, make sure you hit reset all, by the way. What am I going to have to do to my angular velocity in order to maintain the same linear velocity? And so we started out at 360, we doubled the radius, we dropped it to 180, we tripled the radius. Am I going to drop it to 90 degrees per second, or am I going to drop it to like 120 degrees per second? So the big point, this experiment, we're comparing radius and centripetal acceleration. And what we're doing is we're actually changing the angular velocity in order to hold velocity constant as the radius changes.